Okay, next in 4.2.3, composite function. Okay, composite function is function of a function. It means that, okay, normally our function is written in the form of f is a function of variable x, okay, or g is a function of variable x. Okay, but now we have f is a function of x. Now the variable x now is another function. Okay, for example, x now is another function given by hx, for example. So this is what we call composite function. Okay, the notation for composite function is f o h. Okay, if let's say g of x is a function, maybe g is a function of kx. So composite function of g, composite k. Okay, example, let's say given fx as 2x and hx is 1 plus x. Find composite function of f composite h. Okay, f composite h is given by f function of hx. Okay, now replace hx by the given equation 1 plus x. Okay, so now the 1 plus x here is replaced in x here. X here is replaced by the 1 in bracket. Okay, so since f of x is 2x, now since x here is replaced by 1 plus x, so we replace x here by 1 plus x. So it becomes 2, 1 plus x. So simplify it, it becomes 2 plus 2x. Okay, let's say h composite f. So it means that h is a function of f of x. Okay, now f of x is 2x. Okay, h of x is 1 plus x. So h composite, h a function of 2x, replace x here by the new variable, which is 2x. So we have 1 plus x is replaced by 2x. That's it. Okay. Okay, another example, let's say, let's take gx as x square and kx is 1 over 2 minus x. Okay, so find g composite k. G composite k is g of kx. Now kx is given by 1 over 2 minus x. So gx is x square. So now replace x here by 1 over 2 minus x. So we have 1 over 2 minus x square. So the answer is 1 over 2 minus x square. Okay. Okay, how about k composite g? K composite g is k of gx. So k is 1 over 2 minus x. K gx is x square. Replace x here by x square. So we have 1 over 2 minus x square. That's it. Okay, 4.2.5.1 exponential function. Okay, exponential function, we have a curve. Okay, in the form of A is a constant power x. Okay, this is a negative. When A power to positive x, we have the increasing function. For y equal to A is a constant, power to negative x, we have a decreasing function like this. Okay, example, let's say we were to sketch function of y equal to 2 power x. So to sketch y equal to 2 power x, we need to do a table of coordinate x and y. So let's say we take x on the negative and the positive side. For example, let x take a few points on the left and the right. Negative 1, 0, 1 and 2. Okay, so now when x is negative 2, replace x here by negative 2. So y is 2 power negative 2, answer is 1 over 4. When x is negative 1, is y equal 1 over 2. When x is 0, y equal 1. When x is 1, y equal 2. When x is 2, y equal 4. Okay, so from the table here, we plot graph. Okay, when x negative 2, y is 1 over 4. See here. When x is negative 1, y is half. When x is 0, y is 1. When x is 1, y is 2. When x is 2, y is 4. Okay. So let's say we have something like this. So this is y equal to, it should be a curve. Okay, not a straight line, it should be a curve. And it does not pass x-axis. It just close to x-axis but does not pass x-axis. So this is y equal to 2 power x. Okay. Okay, next is exponential. Next is 4.2.5.2 is logarithm function. Okay, logarithm function is an opposite of exponential function. Okay, it is an opposite of logarithm. It is an logarithm function is an opposite of exponential function. Okay, so if we have okay, let's say graph. Earlier we have y equal to 2 power x here. Okay, the inverse of logarithm is an inverse function of y equal to 2 power x. So we have something like this. This is the symmetry, and this one is the y equal to f inverse of x. This logarithm function. Okay, so let's say we have y equal to 2 power x, so ln y is x ln 2 and x is ln 2 or ln y over ln 2. Okay, so this is an opposite of inverse function of exponential. X become a function of y. Okay, x become a function of y. Alright. Okay, 4.2.5.3, last chapter, last subtopic in chapter 4, vertical and horizontal shift. Okay, function, we can shift a function upward, downward, left and right regarding to the function shiftment. Okay, for example, let's say we have y equal to f of x. Okay, now when y is shifted upward, we write the function as f of x plus k. K is a number. Okay, example, let's say f of x is x squared. Okay, now if we have g of x equal to x squared plus 2, so it means that g of x is f of x plus 2. So it means if we have k is 2, so now k is 2. Okay, we shift function f of x 2 points upward. Okay, so f of x is x squared. This is x squared. Okay, so if f of x plus 2, it means that we shift so we shift 2 unit upward. The y is shifted 2 unit upward. So the graph will be, this is 2 unit upward. We have the same shape, x squared, but y is shifted 2 unit upward like this. Okay, the vertex is at 0, 0. Now it is shifted at 0, 2. So 2 unit shifted upward. Okay. Okay. Okay, for y equal to f of x minus k, example, g of x is x squared minus 2, so it is shifted downward, 2 unit downward. Okay, negative 2 here. From here to 0, 0 to 0, 0 to upward plus 2 unit, downward 2 unit. So we have graph like this. This is gx. Okay, so if we have like f of x minus k, for example, earlier f of x is x squared. Earlier we have f of x is x squared. So now if we have f when x is 2, okay, x is 2, so we have x minus 2 square. X minus 2 replace x here, so it becomes x minus 2 square. Okay, so y is shifted 2 unit on the right. From 0, 0 here, 2 unit on the right here. So it becomes like this. Okay, this is x minus 2 square. Okay, if y equal to fx plus k. Okay, example fx plus 2. Since fx is x square, so we have x plus 2 square. So it is shifted on the left. Okay, shifted on the left here, negative 2. So graph will be something like this. So this is y equal to x plus 2 square. Okay, last subtopic 4.3 is application of function. Okay, in real life there are so many application of function, so it depends on the data provided. So either the data provided is a linear form, quadratic, logarithm, exponential, and so on. So it depends on the type of data for the given problem. Okay, example, a common one in economy. Okay, in economy and business and economic, business management, business and economic. Okay, the function involved is profit. It's a profit, revenue, cost, what else? Cost, we have fixed cost and variable cost. It's a common function in business and economics. Okay, we also have demand and supply. Okay, demand and supply function. Demand. This is the function of demand. This is price. This is quantity. Okay, when the quantity is low, when the price is high, quantity is low. Okay, as the price goes down, as the price goes down, the demand for the quantity goes up. Okay, and the supply, something like this. It is the function of supply. Okay, as when the quantity is low, the price of the supply is high. So as the quantity supply is high, the price also goes up. So the meeting point of supply and demand is called equilibrium. This is what is important. This is the important part in economics, where the business people, they try to determine what is the meeting point between the supply and demand of the product. Okay, so there are other more application of functions in the real life. Okay, this is part of the examples. Okay, you can see many more examples in the books, and also in the problem also provided. Okay, the application of functions. Okay, 4.2.4 inverse function. Okay, inverse function is an inverse operation of a variable of a function. Okay, say we have function f of x, where variable x is assigned to input x is assigned to output y. Okay, so now for an inverse function, meaning that from y now become an input and x now become output. So function f here is an inverse operation. Earlier x is an input and y is an output. Now inverse function, it makes y become an input and x is an output. So inverse operation of function is written in this form, f inverse. Okay, so this is called inverse function. Okay, for example, given f x is assigned to 3x plus 5, which means that f of x is 3x plus 5. Now find f inverse. Okay, in order to find f inverse, let's say f inverse is let, okay, this is how we solve, this is how we find an inverse function for f. Let s inverse as a, okay, let f inverse x is a. Now f a, so when we bring f to the right, it becomes f. Okay, f a is x. Okay, so what is f of a? Given earlier, f of x is 3x plus 5. Now f of a means that replace x here by a. So we have 3a plus 5 equal x. So now find a. Since a is f inverse, so we need to find what is a. So from here, do algebra. 3a is x minus 5. A is x minus 5 over 3. So a is f inverse. So therefore we have f inverse x is given by 3x minus 5 over 3. Okay, to another example. Let's say we have in B we have, okay, let's say we take f of x is x minus 3 over 2. So find f inverse. Okay, so we do the same over steps as earlier, as in A. Let f inverse x be A. So f a is x, so replace x here, a by a. So we have x minus 3 over 2. So a is supposed to be a here. A minus 3 over 2 equal x. So a minus 3 equal to x. A is 2x plus 3. So f minus inverse x is 2x plus 3. Okay. Okay, another example. Okay, another example given C. Given fx is 1 over 1 minus x plus 2. Find f inverse. So let f inverse x be a. So f a is x. Replace x here by a. We have 1 over 1 minus a plus 2 equal x. So we have 1 over 1 minus a equal x minus 2. So here we have so we bring x minus 2 here. Okay, 1 minus a equal 1 over x minus 2. 1 minus 1 over x minus 2 is a. Okay, 1 bring here, a is here. Okay, so therefore, or we can further simplify it. X minus 2 minus 1 or x minus 2 minus 1 over x minus 2 equal a. X minus 3 over x minus 2 equal a. So therefore f inverse x given by x minus 3 over x minus 2. That's it.